Kirchhoff's voltage law states that the sum of all the voltages in a closed loop must equal to 0. Here's an example. We have a 3-volt battery attached to 3 identical resistors. On the right hand side, there is a diagram that will help you visualize what is happening to the voltage as we move across the circuit. The height here represents the voltage. We'll start at the negative terminal of the battery, and we start with 0 volts. As you can see on the right hand side, there is nothing. However, as we move across a battery to the positive terminal, we gain the specified voltage. We gain 3 volts. There we go, 3 volts. And we'll write that down. Plus 3 volts. That is how much we gained by crossing the battery. Now we move along to the first resistor, where we lose 1 volt. We always lose resistance at the resistor. So we lose 1 volt. We have 2 volts now. So minus 1 volt. As we move across to the second resistor, we lose another volt. So minus 1 volt again. Minus 1 volt. So we have only 1 volt now, as you can see. And here's the final resistor. Now, how many volts do we lose across this resistor? Well, according to Kirchhoff's voltage law, the sum of all the voltages must be equal to 0. So what is the sum up till right now? Well, it's just 3 volts minus 1 volt minus 1 volt, which is 1 volt, as you can see on here too, 1 volt. That's how much volts we have right now. But when we complete this closed loop, we must have 0 volt, according to this law. So how do we get from 1 volt to 0 volt? Well, we subtract 1 volt, minus 1 volt, and that is exactly what happens at this resistor. We lose 1 volt. And what do we end up with? Well, 3 volts minus 1 volt minus 1 volt minus 1 volt is equal to 0 volt. And here on the right hand side on the diagram, there's nothing again. So the summation of all the voltages across a closed loop is 0.